piecewise function is a function that's defined on two or more intervals. So I've put down here probably one of the most famous piecewise functions called the absolute value function. We've already seen what a plot of the absolute value function looks like. It has a minimum at 0, 0 and opens up in a V shape on either side of its minimum. Now, to be very specific about the absolute value, we define it in two pieces. Over on the right, for all values that are greater than or bigger than 0, we use the line y is equal to x. On the left-hand side, for all values less than 0, we use the line y is equal to negative x. So our two intervals are given over on the right-hand side, although a piecewise function may have more than two pieces. And in our case, this piecewise function, the absolute value function, has two subfunctions. Now let's take a look at how to actually use these subfunctions to help us evaluate the output of a piecewise function. If we want to evaluate a piecewise function, what we have to do is look at our intervals first. So we take the x value that we use as input, take a look at our interval, try to figure out which interval this x input falls on, and then use the subfunction to evaluate. So for example, if we have our absolute value function here, f of x, and we'd like to evaluate f at 5, we're going to use the value of 5. We're going to figure out what interval it's on. Since it's on the first interval here, 5 is greater than or equal to 0, we are going to use the first subfunction to evaluate f at 5. F at 5 is going to be equal to 5. What about f at negative 3? Well, in this case, negative 3 falls on the interval x less than 0, because negative 3 is less than 0. This means when we want to evaluate f at negative 3, we're going to use our second subfunction. So we're going to get negative 3, which is equal to positive 3. Let's take a look at another example of this on the next slide. Let's go ahead and evaluate another piecewise function. Here I've created a brand new piecewise function. We have a first subfunction, x squared minus 3x, if the value we're working with happens to be on the interval x is greater than 1. And our second subfunction is the square root of 8 minus x. We're going to use this subfunction if the input x value happens to be on the interval x is less than or equal to 1. First, let's evaluate f at negative 4. We have to determine which interval negative 4 lies on. Negative 4 happens to lie on our second interval. X is less than or equal to 1. This tells us we should use our second subfunction to evaluate f at negative 4. So let's go ahead and substitute negative 4 in everywhere we see x. So we get square root of 8 minus negative 4. This is the same thing as square root of 12, or 8 plus 4. Now we can simplify this a little bit. We know that the two factors of 12 are 3 and 4. 4 is a perfect square, so let's get rid of the 4. So we are left with 2 square root 3. Next, let's evaluate f at 2. In this case, 2 lies on the interval x is greater than 1. So that tells us we have to use our first subfunction to evaluate f at 2. Making our substitution, we're going to get 2 squared minus 3 times 2. 2 squared is 4, and 3 times 2 is 6. So f at 2 is equal to negative 2. For the last bit of this lesson, I want to give you a strategy to plot a piecewise function. Now, as we work through our first example, I'm going to use the absolute value function, and then we'll take a look at another example afterwards. The key to the first part of plotting a piecewise function is being able to plot all of our subfunctions. So by subfunctions, remember I mean the functions that are inside here before our two intervals. Our first subfunction is y is equal to x. Now this is a line that passes through the origin and has a slope of 1. y equals to x looks something like this. Our second subfunction is y equals to negative x. Again, this is a line that passes through the origin, but now has a slope of -1, so our picture looks something like this. So that's your first step, is to get a good idea of what your subfunctions look like. Now that we know what our subfunctions look like, we move over to our intervals, and we determine which sections of our subfunctions we're going to keep for our final picture. So looking at our first subfunction, y is equal to x, we want to keep the portion of this graph that is greater than or equal to 0. So that means everything on this side of the x-axis. So I'm going to go over this picture in red to indicate what portion of this picture we're going to keep. Now, since we have a greater than or equal to sign, I'm also going to put a solid dot here at the origin, because we're going to keep that point from this first picture. Next, we move over to our second subfunction, which is y is equal to negative x. We want to keep the portion of this picture that is less than 0. That is everything on this side of the x-axis. So once again, I'm going to go ahead and in red, I'm going to color over all of this graph that I want to keep. I'm going to put an open circle here at 0, because we're not going to take the value of 0 here. Once you have the plots of your subfunctions restricted to the intervals that they lie on, the last step of drawing your piecewise function is just to put all of the pieces together like a little bit of a puzzle. Just to refresh your memory on what our subfunctions look like on the restricted intervals, I've plotted them over here on the right-hand side. Let's work from top to bottom. Our first subfunction is x, and it's on the restricted interval x is greater than or equal to 0. That picture looks something like this. So let's go ahead and plot that first on our big picture. Next, our second subfunction is negative x on the restricted interval x is less than 0. And that part of the picture looks like this. When we go to plot our open circle, it's just going to go around the already closed circle, and we're going to get an overall picture that looks like this. So here is the absolute value function, pieced together as a piecewise function. Let's try to plot the following piecewise function. G of x is going to have 3 subfunctions. X squared, if x is less than -2. 4, if x is between -2 and 2. And the square root of x, if x is greater than or equal to 2. Now, just like before, we want to divide this up into 3 separate parts and consider each subfunction on its own. Our first subfunction is y equals to x squared. This is a parabola that has a minimum at 0, 0, and opens up like a U on either side. So here's a rough sketch of y equals x squared. Our next subfunction is y is equal to 4. This is a horizontal line that's going to pass through the point 0, 4. And finally, our third subfunction is the square root of x. The square root of x begins at the origin and opens up like this to the right. Now that we have a rough idea of what our subfunctions look like, we need to restrict them to the intervals that are given. Just to remind you of what the intervals are, I've plotted them down here. Looking at our first function, y equals to x squared, we need to find the portion that's less than -2. So here, I am going to actually plot an open circle on our parabola where x is equal to -2. So we have -2 and 4. We want everything less than this open circle. So that's going to include this whole portion over here. Next, let's work with y is equal to 4. We need to restrict this picture to the bound x is between -2 and +2. Now this means there's going to be 2 open circles on this line. There's going to be one here at -2. Here we're going to get the point -2, 4. And there's going to be another open circle here at the value of x is equal to 2. And again, the y-coordinate here is going to be equal to 4. And we want everything that's in between. Lastly, dealing with our square root function, we want everything greater than or equal to 2. So let's go ahead and plot a closed circle here at the value of x is equal to 2. When we substitute 2 into y, we're going to get square root of 2. So the point here is going to be 2 root 2. And we want everything to the right of this point, so everything over here. Putting this all together, we have the following. So at the point -2, 4, we are going to have an open circle if we're going to have that part of the parabola. Then between -2 and +2, we're going to have a closed horizontal line with another open circle here at 2, 4. Finally, we put in our last bit of the picture, that's the square root portion. We're going to have a closed circle at 2 square root of 2. That's going to be somewhere around here. And then everything greater than 2 is going to look like this. All right, my little epsilons, stay positive.